Hello, in this video I am going to explain what are forced oscillations which comes under module 1 of VTU syllabus. So forced oscillations. Oscillations that result when an external oscillating force is applied to the particle subject to simple harmonic motion. For example, a child on a swing can be kept in motion by appropriately timed pushes. The amplitude of motion remains constant if the energy input per cycle of motion exactly equals to the decrease in mechanical energy in each cycle that results from resistive forces. Vibrations of tuning fork placed on a resonating box makes the wall of the box and the air inside oscillate. Let F is equal to F naught cos omega F into T be the oscillation or oscillating applied force. The equation of motion is given by F is equal to ma, that is equal to minus kx plus bv plus F naught cos omega F into T. Further, we can write it as m into d square x by dt square plus b into dx by dt plus kx is equal to f naught cos omega f into t. So consider this as equation number 1, and the next slide let us discuss about x of c into t. This equation is non-homogeneous. The complementary function is given by x of c into t is equal to c of cos omega f into t plus d into sin omega f into t. So consider this as equation number 2. So here x of c into t is equal to a cos omega naught into t minus theta, where a is equal to square root of c square plus d square, and tan theta is equal to d by c. So consider this as equation number 3 now. The sine and cosine terms on both the sides can be expressed as k minus m omega f square into a plus db omega f is equal to f naught minus bc omega f plus k minus m omega f square into d is equal to 0. By solving for c and d, we will get the value of c as c is equal to f naught into k minus m omega f square divided by k minus m omega f square whole square plus b square omega f square, and the value of d is equal to f naught into b omega f divided by k minus m omega f square whole square plus b square omega f square. The general solution is x of t, and the value of x of t can be written as a cos omega naught t minus theta. Here the amplitude a is equal to square root of c square plus d square, and phase theta is equal to tan inverse d by c, that is equal to tan inverse b omega f divided by m into omega naught square minus omega f square. Next, let us discuss about the three cases. Here, the first case is omega f is less than omega naught. So here the value of a is approximately equal to f naught divided by k into 1 minus omega f by omega naught whole square. And the second case is omega f is equal to omega naught when the frequency of the applied force is same as natural frequency of the oscillator. Resonance occurs. Maximum transfer of energy takes place by that time. The third case is omega f is greater than omega naught. So here the value of a is approximately equal to f naught by m omega square cos omega t. So here we have to consider phase log between the applied force and displacement increases from 0 to pi by 2 as driving frequency increases from 0 to omega naught. Next, so here is a chart, and we are plotting a graph of amplitude versus frequency, and here you can see three curves. The first curve for which the value of b is equal to 0, and the middle curve for which the value of b is low, and the last one for which the value of b is equal to very large. Next, I am going to consider the electrical circuit in which LC are connected. So for which Q by C plus R into dQ by dt plus L into d square Q by dt square is equal to V cap. And further, I am going to explain what is I cap. That is I cap is equal to dQ cap by dt, that is equal to I omega Q cap. And finally, V cap is equal to I cap into Z cap. Next, I will explain the different examples of resonance. The first one is oscillations of the stretched string kept under the influence of oscillating magnetic field caused by oscillating current. The string vibrates with maximum amplitude when the applied frequency matches with natural frequency of the string. The second one is we have to consider the NaCl crystal. If an electric field is applied on the crystal, the charges would oscillate back and forth, and the natural frequency is in infrared range. So here is a chart, and if we plot a graph of angular frequency versus natural frequency, the curve obtained is as shown in the diagram. And when the value of omega is equal to omega naught, the value of P becomes maximum. So here omega naught is considered as the resonance frequency. Next, the third case. So when the LC circuit in a radio tuner is tuned to radio station frequency matches with the natural frequency, so F is equal to 1 by 2 pi into square root of LC for amplifications of signals. The third one is already explained. Now the fourth one is Helmholtz resonator. It is used to analyze complex note. It consists of a hollow sphere of thin glass or brass with an opening through a narrow neck. It is filled with air. The opening receives exciting sound waves, and the air are kept close to the neck. When air is pushed into the sphere and released, the pressure will drive it out. The volume of air in the container behaves as a mass on a spring which is pulled down and released. Compressed air tends to move out and creates low pressure inside. The air will oscillate into and out of the container at its natural frequency given by F is equal to V by 2 pi into square root of A divided by LV. So here V is the velocity of sound, L is length of the resonator, A is the area of the opening, and V is the volume of the resonator. Next, I want to explain what is quality factor. It is a customary to describe the amount of damping with a frequency called the quality factor denoted by symbol Q. It is defined as the number of cycles required for the energy to fall off by a factor which is equal to 535. A mechanical device that can vibrate for many oscillations before it loses a significant fraction of its energy would be considered a high quality device. Let W be the amount of work done by friction in the first cycle of oscillation, that is, the amount of energy lost to heat. Let the original energy be capital E. So by that time we can write 1 by Q, that is 1 by quality factor, is equal to 1 by 2 pi into W by E. The full width of half maxima, that can be written as FWHM of a resonance, is related to its quality factor Q and its resonant frequency, that is FRES, by the equation that is FWHM is equal to FRES by Q. So, thank you.